Last time we talked about a database called SQLite, and we saw that we could access it from Python to store data and perform queries against that data. Today we're going to talk about a more powerful database, a database called PostgreSQL, and we'll talk about how we can use PostgreSQL from Python. So SQLite had a lot of advantages. Because it stores everything in a single file, we saw that we can copy that file from one computer to another, and we can use that to back up the database. But we can also use it to port the database from one system to another for production purposes when we're ready to move from testing to production. There's a lot of other things that we can do. But SQLite also has some drawbacks. It's not really designed for performance. Because all of its actions are performed as file accesses, it's actually pretty slow. And so if we had millions of simultaneous queries, we probably wouldn't want to use SQLite. Now, for most projects, that's not a big issue. If we're just throwing together a real quick website, maybe a mock-up of something, or if we don't expect to have millions of users or lots of hits, then maybe SQLite is exactly what we want. But if we want something that'll scale, then we probably need to switch to a different model, a different database server. And so we're going to use something like MySQL or Postgres. SQLite also isn't designed to be run as a server. Again, it's designed to store everything in a single file, and it's really just sort of an interface on top of that file. So if we want to provide network access to that data, we have to write some sort of application to do that. Maybe we write it with Flask. But with Postgres, we're going to be able to run the database on a separate server, and we're going to be able to access the data over the network. It doesn't support foreign key constraints. It does actually support some other kinds of constraints, like a primary key constraint and some nice check constraints. But if we want to have foreign key constraints, which are pretty important in database design, then something like Postgres is probably better. We saw before that it doesn't have any built-in cryptographic hash functions. That's not really a big deal because we can do that in Python instead. But it's a convenience that it's available in Python. In Postgres. And it doesn't have very good full text support. That's becoming more important. If I'm developing something like a search engine, I need a way to search through a document that has thousands of words and say, okay, which of these documents have this keyword? And how many times does this word appear? And there's a lot of new research that's happening on full text databases. In fact, some of the really exciting NoSQL databases are really designed for document handling and for taking a bunch of blog posts and extracting all the interesting information from them. But SQLite's not really designed for that. It can do some things, but not very many. And so something like Postgres that provides regular expressions and some better keyword matching is really nice. So what is PostgreSQL? Well, it's an ACID-compliant database. All good modern databases are. Any good modern relational database anyway. It was developed at UC Berkeley in the 80s as a database called Postgres, and then SQL support was added in 1994, and so they renamed it PostgreSQL. So it's actually a pretty old piece of software, but it's aged very well. In fact, the code is in really great shape. It's an open source project, so you can actually download the source code and see how Postgres is written, and if you want to, make changes to it, and then share your changes with the community. And so I encourage you to do that. If you have some time, go to the Postgres website and download a tarball of the source code and just open it up and see what you can do. But another advantage of an open source project is that there's no licensing fees associated with it. And so in an age when databases often came with some pretty hefty licensing fees, databases like MySQL and Postgres that were open source became popular very quickly because from a business point of view, it's nice not to have to pay licensing fees to use your software. It also has some great management tools. In particular, it has some great tools for creating users and groups of users and setting permissions on the database. This is the main feature that is the reason I prefer Postgres to MySQL. I like both database systems. MySQL is great too, but I tend to prefer Postgres because it's very easy for me to create users, set passwords, and then grant permissions on the databases. I think it's much easier in Postgres than in MySQL. So that's kind of the killer feature for me. It also has very simple network configuration. You can do a lot of that configuration by just editing a text file. And Postgres is very fast and memory efficient, so it scales very well. In my experience, it tends to do just as well as MySQL, and it's a lot easier to use, especially when I'm working with very large data sets. So how do we create a Postgres database? Well, with SQLite, we use the SQLite 3 utility. Postgres also comes with a database utility. It's called PSQL. And you can just type PSQL at the Linux command prompt. It does take several options. So one option is a host name. We have to tell PSQL which server to connect to. So by default, it'll just try to connect to your computer, the one you're running the command on. And if you're logged into Gandalf, that will work just fine. But if you're logged into some other system, you would need to say PSQL-H, gandalf.cs.longwood.edu, and then PSQL would connect to Gandalf and try to pull up your database. We also might need to specify a username, so -U and a username will tell it which user to log in as, and -d and a database name will tell it which database to connect to. So it's kind of a style thing if you're creating a database for particular users on your system to give them the same database name as username. So that's what I've done here. So I've got a database named Robert that's owned by the user Robert, and I'm connecting to it on Gandalf. Once you've done that, it'll pull up this nice utility. It has command history, so if you push the up and down arrows, you can scroll back through the last couple commands you've typed and run them again or edit them. There's a lot of other nice features. It has some tab completion, so you can type part of a command and hit tab, and it'll finish typing the rest of the command for you if it can figure out what you meant. So it's a very nice utility. And we can type SQL commands into the utility and hit enter, and they'll run directly on the database. So for example, I can create a table named trucks that has two columns, a make and a model, both of which are text columns, text fields. And when I hit enter, Postgres will create that table, and it'll tell me a message that says it succeeded, basically. OK, once I've done that, I can use the PSQL tool to insert data. So I can say insert into, and the name of the table is trucks, and my columns are make and model, and I'm going to put the values Ford and F-150 into the database. So if you remember how this works, it takes the first column and the first value and pairs them up, and the second column and the second value and pairs them up. So it's going to create a new row in the table named trucks, and the first column of that row is going to have the value Ford, because that's the make, and then for the model, it's going to have F-150. It turns out in Postgres, we can actually simplify the syntax a little bit. For example, I don't have to specify every column. So for example, I can insert into the table named trucks a row that just has a make. So I'm going to tell it that the make is Tonka, and I'm not going to give it a model. I don't even know if Tonka trucks have make and model. But I can omit the model, and what will happen is Postgres will put in a null for me. It'll basically leave the model field blank. So there'll be this row that has Tonka for the make, and then nothing for the model. As another matter of convenience, you can actually leave out the list of columns. You can just say insert into, and then the name of the table, which in this case is trucks, and then the keyword values, and we can put in the values to insert. So here, I'm going to tell it to insert Toyota and Tundra, and it will automatically put Toyota in for the make and Tundra in for the model. And when you're done, you can quit. In SQLite, we typed .quit to exit the utility, but Postgres, again, is a little different. To quit, we type \q and hit enter. I think you can actually type \quit, and that will work also, but it's shorter to just type \q and hit enter. You can also hit Control-D. For some reason, that logs you out, I guess because it's the end of file character. In general, Postgres commands in the PSQL utility will start with a / instead of with a dot. So here are some other useful commands. \? Pulls up the help. It gives you a list of all those useful commands, and there's quite a few of them, several hundred, and you're probably not going to need them all, but if you want to pull up the help, it's there. \DT will list all the tables in the database. That can be useful. It'll even tell you what columns are in each database. And then you can say \DG to list all the users that are available on the server, and \L will list all the databases that are available. So we've got a list of databases, list of tables within a database, list of users on the server. So just as we can connect to an SQLite database using Python, we can connect to a Postgres database using Python. In SQLite, we imported the library named SQLite 3. There's actually several different libraries that will let us access Postgres from Python. My favorite is something called psycopg2, and we're going to use psycopg2 as our connector library, or our binding. But it turns out there's actually several others that are popular. There's one called PG8000 that I've used, another one called PostgreSQL, And there's probably 4 or 5 different libraries, and they have different advantages and disadvantages. But I think PsychoPG is probably the most popular way to connect. Actually, we're going to see that a lot of people in industry don't actually do this directly. They use a higher level library that's kind of a wrapper around PsychoPG, something called an object relational mapper, like SQL Alchemy. I'm not going to show you SQL Alchemy in this lecture. I may show it to you later. I encourage you to read more about it for glitter, maybe. So just as we did with SQLite, we're going to connect to the database using the connect function. And so we're going to say db equals psychopg2.connect. But this is a lot more complicated than SQLite. In SQLite, to connect, we just had to tell it the file name, because it just had to find that file. And once it found the file, it could do SQL commands. But with PsychoPG2, we're actually connecting to a database across a network. So we have to tell it a lot more information. One of the things we have to tell it is the host name. We have to tell it what server to connect to look for the database. So here we've said the host is gandalf.cs.longwood.edu. You can either put a host name in or an IP address. We also need to tell it which database on that server to connect to. Remember, Postgres is a database server. It can actually be serving several different databases for different web applications or for different users, different purposes. And for example, on the server, each of you is going to have your own database that you can use for Lab 7. So we have to tell it the name of the database. And so, for example, I've named this database Student 60. We also have to tell it what user to try to connect to the database as. So we have to specify the username, which in this example is also student 60. And then we need some sort of credential that will allow us to connect. And so I've chosen to use the password ISCS375. Like I said before, I've created a database for each of you to use on Lab 7. And it's on Gandalf. And what I've done is I've created a database with your username. So the name of your database will be student 5 or student 20. Your username will also be student 5 or student 20, and your password will be just what it is here, ISCS375. Now, this is obviously not very secure, especially because I'm telling the entire world what those passwords are in this video. And if this were a real production system, you would never do anything like that. And you would probably encrypt the password in some way or use public key encryption to authenticate. But we're not going to do that. We don't have any sensitive data on the database server, so we're just going to ignore the security concerns for now and move on. Just as we did before, we need to have a cursor object that will actually allow us to execute the queries. So we say cur gets db.cursor, and we have our cursor object. This is fine. This is all we have to do if we want our queries to return a list of tuples. And then we can say rows equals db.fetchAll or fetch1, and we can say row sub 0 and row sub 1, row sub 2. But if we want to use that special cursor that allows us to access the rows as dictionaries instead, where we can say instead of row sub 0 or row sub 1, we can say row sub and then the column name, then we have to do a little bit more work when we create the cursor. And so the way that that's done with PsychoPG is to set cur equal to db.cursor, and then inside the parentheses, we pass a named parameter. We set cursor factory equal to psychopg2.extras.realDictCursor. Capital R, capital D, capital C. And this will just basically tell it when we execute a query, instead of giving us back a list of tuples or a list of lists, give us back a list of mappings, a list of dictionaries, or a list of what's called an associative array in computer science. So a list of associative arrays. So once we've done that, the SQL queries are pretty much the same. So I can say cur.execute, create table users, and give it 3 columns, a name, which is text, a score, which is an integer, and a last login field, which is a date. I can also use cur.execute to run an insert statement. So I can say insert into users, name, comma, score, the value Spidey, comma, 600. Actually, we saw before I could have left out the name and score and just said insert into users, value Spidey, comma, 600. Notice that I omitted the last login. That's going to just become some default value or be a null. Once I've done that, if I want to actually save my data, I have to either do db.commit or db.rollback to abort. Running select queries is a little bit different, though. So with SQLite, if I wanted to run a select query, I had to put question marks in as placeholders. In PsychoPG, we actually use a different syntax. So if I want to put in a string placeholder, I put in a %s. If I want to put in an integer, I say %d. The d stands for decimal because integers are decimal numbers. They're in base 10. So %s and %d are going to be my placeholders. And so I can do something like this. I can run some function that will get the number of years someone's been employed and put that in a variable named employed. I can call another function that gets some minimum age and store that in min age. And then I can say cur.execute, and I'm going to query the database to see anybody whose length of employment is that number of years of employment and whose age is less than the minimum. So select name and salary from records where length of employment is, and then I say %s, that's my string placeholder, and age is less than %d is my integer placeholder. The real difference here is that if you put in a %s, it's going to put quote marks around it for you. If you put in a %d, it thinks it's a number, so it won't. Anyway, the rest of this is the same. You put in you close your quotes and you put a comma, and then in square brackets, because we have to have a list, you put the list of values to substitute in for the placeholders. So it's going to put employed in for the %s, because employed is the first thing in the list, and the %s is the first placeholder. And then it's going to put min age in for the %d, because min age is the second thing in the list, and %d is the second placeholder. I can have as many %s's and %d's as I want, and I just have to make sure that my list is the same size as the number of placeholders. After I've done my select query, I can use cur.fetchAll to get all the rows that match. And then I can use a for loop to loop through. And if I've done my real dict cursor in my db.cursor function, then I can print out the name by saying print name, comma, row sub name, print salary colon row sub salary. And I can just use the column names from the database here. So I just select on name and salary. Now I can say row sub name and row sub salary because I'm using that real dict cursor. If I didn't do that, I'd have to say like row sub 0, row sub 1, and I'd have to be very careful to make sure it matched what's in the select statement. The advantage of this from a software engineering point of view is that now if I change the order of the things in my select statement, or if I add a new column or something like that, I don't have to change the things in my for loop because they're indexed by the field name, not by position. Much safer, much less likely to cause bugs. So when I'm done with my queries, I need to clean up. So I can say db.commit and cur.close and db.close, or I can use the with syntax that we learned last time. So I can say with cyclopg2.connect and my big long connect string as db colon, and then I have to indent my code. So I can create my cursor and I can insert a value into my users table, and then I can close the cursor, and then at the end I close my database. I don't have to commit because the with structure takes care of that for me. So why would I want to use PostgreSQL instead of SQLite? We talked about some of the disadvantages of SQLite earlier, but let's see some of the advantages of Postgres. So it provides better constraints. So for example, if I create an employees table that has a name and an age, I can mark that name as a primary key. I just say name, text field, primary key. And a primary key is just, it's a unique non-null field. What does that mean? It basically means that every record in the employees table has to have a name. I can't leave that blank. And it has to have a unique name. I can't have two different employees with the same name in the database. So this is just for safety to make sure I don't accidentally put in duplicate data, basically, or that I don't put in bad data that's missing an important field. You can do this in SQLite, and you can do it in Postgres. So you can say primary key to mark a field as unique and non-null. However, in Postgres, I can have what's called a foreign key, and I can't do that in SQLite. In Postgres, we use the keyword references to add a foreign key. So for example, here I can create a second table named salaries that has two fields, a name, which is text and is a primary key, and a salary field, which is just an amount of money. That's another thing you can do in Postgres. You can have a money type, and it'll format it nicely when it prints it out. But notice what I can do after it says text primary key. I can say it references the employees table, the name field. In other words, the name in the salaries table is the same as the name in the employees field. And what this will do is it's not going to let me put something into the salaries database unless there's a matching name in the employees table. So if you're not employed at the company and you don't have your age recorded in that table, you can't get a salary. It won't let you put a salary in. That's just another safeguard that's really useful when you're designing a database. Postgres also provides some pretty good text searching capabilities. Some of the new NoSQL databases have even more powerful features, and they're even faster at this kind of thing. But Postgres isn't bad. Probably the simplest and easiest one to use is the like or I like keyword. So suppose I made a table named documents, and it just has two fields. It has a title and a body. So maybe this is a blog post. I'm putting blog posts into a database, and my blog post has a title, and then there's the body of there's the body of the post, the actual text that they typed in, their rant or whatever it is. Now I want to search for blog posts that have the word dog in them. They mention dogs in some way. So I could say select title, because I just want to print out the title. I don't want to print out the whole thing. From documents, where, and then I could say body I like, and in single quotes I'm going to say %dog%. And what's going on here is that I like is going to search through the body for strings that match this regular expression, %dog%. So percent is a wild card that means anything. So anything followed by the letters DOG followed by anything. So if that body has the word dog in it anywhere, it's going to match. And there's two different operators like this. There's one called like and one called I like. The difference is that I like ignores case. So it doesn't matter whether dog is lowercase or uppercase, or the first letter is uppercase and the rest are lowercase. It's going to match if it has the letters DOG in it. You can also do more sophisticated things in Postgres. You can use regular expressions. So it's a really powerful query language. It also provides some nice built-in functions. So we saw before with SQLite that I couldn't directly use cryptographic hashes. But in Postgres, I can. So for example, I could insert into a table named users a name and a password. And the values are going to be Mary is my name. And my password will be the MD5 hash of the word Christmas. So I'm going to put Merry Christmas into my database. Mary will be my name. But before it puts Christmas into the database, it's going to hash it. So it's going to actually put this big, long string of letters and numbers in, 81B616FB FF55B869804452F4 5C08630. That's what it's going to put into the table because that's the MD5 hash of the word Christmas. Another function is the now function, which returns the current date and time. So you could say select now, and it'll tell you what time it is. You could select count of name from users. It'll actually go through a table and count how many times, or count how many names there are. And so that's a way of getting an idea of how many records are in your table. I think you can actually do that in SQLite, because SQLite does provide some aggregates. But we can also do things like this. We can say select name, comma, length of name from users. And so that'll print out a table that shows all the names in the users table and how many characters long they are. So for example, Fred would be 4, and Mary would be 4, but Joseph would, I think, be 5, 6. Joseph would be 6. So let's put all this together and make kind of an example. Suppose we want to put together just a login screen. So we're going to ask for a username and a password. And when they type in their username and their password, we're going to go check the database and see if the password is correct. So we need to create a database that's going to have just one table, a users table, that has a username and a password. And we're going to use MD5 hashing to encrypt the password. Actually, MD5 is no longer considered that secure. SHA-1 is a much better hash function. But the first thing that we have to do is make a web page for the login screen. So we're going to make a file named template/login.html that we can render as a Jinja template. So we've got our doc type tag and our HTML tag. We've got our head and title tags and our body and our /body tag. And in between, we've got an H2 header that says please log in, and then a form. And that form is going to call the secret route in Flask. So the action is secret. And we're going to use the post method. It basically just has two inputs, one for the user, one for the password, and then it has a submit button. So pretty straightforward. Now that we've got a login form, we actually have to make it do something. So we're going to write a Flask controller. So we import all the usual things from Flask, but we're also going to import psychopg2 so we can talk to the database, and a library called hashlib that will let us do some MD5 hashing. So again, we create our Flask application by saying app equals flask of underscore underscore name underscore underscore. And then we're gonna make a root, and we're gonna make a root for the default path, the slash URL. And we're gonna map that to a function named main that's just gonna render the login page. So if they pull up lab 7 or whatever our URL is, it's gonna pull up this page with a login form. Notice we haven't actually mapped secret to anything yet. We're going to do that in the next slide. As usual, we have our if statement that checks if we're supposed to run the server, and if we are, it runs the server on port 6000, which is the one that I've set up for Olivia and I to use. You'll, of course, have to put your own port number here for lab 7. So now we need a function that will process the form and check the password. So we're going to map the root /secret with the method post to this function, which I've just named secret. So the idea here is if they type the correct password, it's going to give them a page that just says, you found the secret message. If you look at the bottom here, you can see that we return that. Otherwise, it's just going to redirect them back to the login form so they have to try again. So the first thing we do is we get the form from the web page with form gets request.form. And then if I were to do this properly, I would check with an if statement if they typed in a username and if they typed in a password. I'm not going to do that because I don't have room on the slide to fit everything if I do. In my actual code, I do have those if statements. But I can fetch the username from the form and fetch the password from the form, just as we've been doing since we started using Flask. And then I want to take the password they typed in, and I want to encrypt it so that I can compare the encrypted string with the encrypted string in the database. Because remember, I don't want to store the password in plain text in the database. If I do, anybody who can access the database can see all the passwords. And since users have a tendency to use the same password on multiple different websites, this would be a bad thing. If I ever get compromised, I'm not just exposing myself, but I'm exposing everybody else. So you should always encrypt passwords before storing them in a file or in a database. So that's what we're going to do. So if we want to check if the password's correct, we first have to encrypt it and then compare the encrypted strings. To do that, I create an MD5 object by saying MD5 gets hashlib.md5. Hashlib provides several different hashes, but MD5 is the one we're going to use. And then I put the password they typed in into the MD5 object by calling the update function. So here I'm saying MD5.update, and in parentheses I'm saying password.encode of UTF-8. You have to do this because recent versions of Python store strings in Unicode. And if you don't encode the string that came back from the web form as a Unicode version 8 string, a UTF-8 string, hashlib complains. It gives you an error about the string not being properly encoded. Then once I've done that, I can fetch what's called the hex digest. That's the encrypted string from the MD5 module by saying encrypted PW equals MD5.hexdigest. So now I've got my username, and I've got this variable named encrypted PW that has the hashed password. And now I can connect to the database. I'm going to use my with construct. So I'm going to say with psychopg2.connect. I'm going to pass in the database name as Olivia and the user as Olivia. I don't have to put the host name in this case because this is going to run on Gandalf. So by default, it'll try to connect to itself, which will work. Then I can say, I've named this DB. So I can say C equals db.cursor to create a cursor named C. And then I can say c.execute select password from users where username equals, and I put my %s placeholder in. And then in my list, I put the username. So it's going to replace that %s with the username that was typed into the web form. So now it's going to the database, and it's searching through all of the user accounts for one that has that username. And if it finds one, it takes the password and puts it into the list. And if it finds another one, it's going to take it and put it into the list. So if I have several different passwords for the same user, I'm going to get a list of passwords. Hopefully that doesn't happen. Hopefully each user has exactly one password. But either way, I'm going to fetch all of the rows, all of the passwords that matched, into a variable named rows. I'm going to loop through all the things in that list that it returned. And I'm going to check if row sub 0, that's the password, for this row is the same as my encrypted password. So I said if the encrypted password is row sub 0, Then I'm going to print, you found the secret message. And since I'm returning, at that point, the function will stop. If that wasn't the correct password, it'll keep looping to see if there was some other password in the list that matches. And if not, if it gets through all the passwords for that user and none of them worked, then it's going to redirect back to the function, the main function, and print out the login form again. So it'll render the template, the login.html template again. So in Lab 6, you might have noticed that URL4 didn't always work right. It would basically take out your username and stuff if you weren't careful. The reason for this is that Gandalf is accessible from your school's network, but only on port 80. And so if you were running Flask on port 5000 or 5001, you wouldn't be able to get into your server from Henrico. And so what I've done, I've actually set up a proxy on Gandalf that forwards your connections to certain URLs to specific ports on the server. And Flask didn't like that very much because it didn't know how to rewrite it when it went back. So one way to get around this and make things work at least a little bit better is to use something called WSGI. WSGI, WSGI, is a Python framework for doing web manipulation. And it replaces CGI. It's kind of an advanced form of CGI. And Flask is built on top of WSGI. And there's a WSGI module for the Apache web server I'm using as a proxy that will make this easier. But if we want to be able to use WSGI, you actually have to create a file that will tell WSGI where to find your Flask application. So you want to create something like this. So this is what I've done. I've made a lab7.wsgi file in my folder. And it's got the magic at the top that runs Python. And then it imports the system library. And it adds to the path this folder at the beginning of the path. So in position 0, it adds Scratch, IS375, Olivia, Public HTML Lab 7. You'll need to do that, but you'll have to replace Olivia with your username. So student 2, student 5, student 30, whatever. And then from Lab 7, which is the name of my .py file, import app as application. And if you do that, then you'll be able to go to your Lab 7 folder and pull it up through WSGI, and you won't have a lot of difficulty accessing things in Flask. So let me actually show you what this web application looks like. So here's the login screen. Oh, I guess you can't see that very well. Let me zoom back in a little bit more. Here's the login screen. And so I can type all sorts of things here. I can type Fred, and let's type in $. And click Submit. And there is no user Fred in the database. So when it tries to find a password, it doesn't match. However, I did put Robert into the database with the password 12345. So if I put in a correct password and click Submit, or maybe it's Bob with 12345. Sure enough, it's Bob. It prints you found the secret message. So that's our application. So in summary, you can use the CyclePG2 module to access Postgres across the network from your Python scripts. If you want to perform queries, you have to first connect to the database. Connecting to the database is a little bit more complicated. You have to specify a host name, a username, a password, and a database name most of the time. You also have to create a cursor. A good way to create a cursor is to use the real dict cursor option, which will allow you to access the fields of your rows as dictionaries instead of tuples. To execute a query, you use select, but select uses a different kind of placeholder from SQLite. It uses %s and %d for strings and decimal formatted integers. And just as we did with SQLite, once you've done your select, you can do a fetch all.